In this video, we're building a machine learning-powered AI resume analyzer using Python and Flask. The application allows users to upload their resume and paste a real job description URL, which is automatically scraped in real time. Using natural language processing and machine learning, the system compares the resume against the job description and generates an ATS-style match score. Our project structure is clean and simple. We have two main files. app.py, which contains all the business logic, machine learning, and web scraping. And index.html, located inside the templates folder, which handles the user interface. Let's start building.
Let's gather our squad. We need Flask to build the website, PyPDF2 to read uploaded resumes, and Beautiful Soup to scrape job descriptions from the web. The real MVP here is Scikit-Learn. That's our AI brain that will do the math to compare the text. We initialize the application. This is just standard procedure to tell Python, hey, this is a web app now. Most resumes are PDFs, which computers find hard to read directly. This function acts as a translator. It opens the PDF, goes through every page, and rips out the raw text so our AI can process it. If it's a simple text file, we just read it directly. We need to know what the company is looking for. This function visits the job URL you provide. We use a fake user agent so the website thinks we are a real browser and doesn't block our bot. Websites are full of invisible junk like JavaScript and CSS. We don't want to analyze that. Here, we strip out all the code tags so we are left with just the clean, human-readable text of the job description. Here is the AI magic. Computers can't read English, so TF-IDF Vectorizer turns words into numbers, e-vectors. Then, cosine similarity calculates the angle between your resume vector and the job description vector. The closer the angle, the better the match. This is our traffic controller. We set score and error to none initially because when the user first visits the page, nothing has happened yet. When the user clicks Analyze, a post request, we grab the uploaded file and the URL. We run our extraction and scraping functions to get the text, and then pass both texts into the AI model to get our score. Things break. Maybe the URL is bad or the PDF is encrypted. This try-exceptor block is our safety net. Instead of crashing the whole server, we just show a polite error message to the user. Finally, we send the data back to the web page. We pass the score if we have won, or the error if we failed, so the HTML can display the result. The ignition key. This starts our local web server. Debug equals true is great for development because it reloads the server automatically whenever you save changes to the code. Setting the stage. We're using a CDN link to pull in Tailwind CSS. This saves us from writing a separate CSS file and lets us style the page instantly using utility classes. We want that modern dark mode look. BG Slate L900 gives us a dark background, and Flex Item Center Justify Center perfectly centers our card in the middle of the screen. This creates the main card container. We give it a slightly lighter background, Slate 800, so it pops off the screen, and rounded corners for a modern feel. Here is the input zone. Crucial note, enttype equals multipart form data is required when uploading files. Without it, the browser sends the file name but not the actual PDF content. We add a URL input for the job link and a submit button. The hover BG Blue 600 class gives the button a nice interactive effect when you mouse over it. This is Ginger 2 logic, Python inside HTML. This block only appears if the Python backend calculated a score. It dynamically inserts the score, a variable, right into the HTML. Just like the score, we only show this error message if something went wrong. It keeps the UI clean until we actually have something to tell the user.